Welcome back to Cloud 42, I'm James. This is the last video in a 6-part series on installing a variable frequency drive into my Grizzly G0602 lathe. We've already got the motor installed in the lathe, we've got the electronics on the wall, and the last thing we need to do is hook up the controls to control the VFD. Let me grab a screwdriver and let's get started. Okay, this is the existing control panel on the lathe, and there's an e-stop switch, a start switch, and a direction control. Now, the habit I've gotten into when using this lathe is to always use the e-stop switch to stop it. And that's fine if it's just a capacitor motor and I'm just turning the contactor on and off. But with the VFD, I would really like to repurpose this and use it probably the way the lathe was intended, which is pull out the e-stop switch and hit the green button to power up the lathe, and then you actually control the lathe in operation by switching it forward, reverse, and stop. So switch it on to run and stop. And so what I'm planning to do is wire this up so that the e-stop switch and the green button control the contactor, which will then power up the VFD, and then this switch will control the signals, the forward and reverse signals to the VFD to actually run the motor. And we'll see how that goes. And in the end, if I don't like it, it's easy to change. The one thing that I want to do before I pull this off is this is the speed control potentiometer, and I want to mount it right here. And I've already marked and center punched a hole where I plan to put this in. And I want to go ahead and drill the hole while this is all mounted on the lathe. I've already looked, there's nothing behind here that I'm going to hit with the drill, and it's a lot easier just to do it here rather than take this off and then have this big floppy curved piece of metal and figure out how to clamp it and how to hang on to it. So I'm just going to grab a cordless drill and we're going to pop a hole in there. Pilot it with something smaller first. And aluminum panel just cuts like butter. Now let's see if we can do this without making a triangular hole. There we go. Does that fit? And that fits. Now, I wanted to mount this direction. There's a little tiny ear here, and I'd like to make a little relief hole for that to keep it from rotating. So let me put it in here and use that to mark the location. We'll center punch it. Let's see, how big does that hole need to be? That's about right. And then we'll pop a second little hole there. Okay, and that fits beautifully. Now, of course, when it's on the inside, it'll be this direction. Okay, let me grab some tools and let's go ahead and pull that open. Okay, this is just a matter of taking out all the screws. Okay, now I've already taken the wiring off of the back of this thing. This thing had a whole bunch of cables that were part of the original setup to control the contactor and the capacitors to change the motor direction. And all of that was in here, and I've just disconnected it from the switches and pulled it out the back. So it's out of our way. Now let's take this control panel over to the bench and look at what we've got going on with the switches and get our new cabling hooked up. Okay, this is the control panel off of the lathe with the controls we already looked at. Let's look at what we've got on the back here. So the stop switch and the start switch are both modular switch systems. So there's a frame for the switch, and then there's one or two, and actually because of the way this works you can stack them up, additional switch modules that are on the back. So the start switch has a normally open switch, which means that it's not connected until you press the button and then it makes electrical contact. The stop switch has a normally closed switch, meaning that when the stop switch is out, it's closed, the circuit's closed, the circuit is on. And when you press it in, that turns the circuit off, which is exactly what you would expect from the stop switch. Now, this barrel switch in the center for left and right is actually a modular switch. Let me see if I can get this where you can see it. There are actually 3 switch modules stacked up, and these are modular devices, and you can stack up as many as you want or as many as you need for your application. And I spent a little bit of time with a continuity tester trying to figure out exactly how this switch works, and it's relatively straightforward. Let me see if you can see this. I've marked the module closest to the switch body with an F for forward, and the module out here with R for reverse. And what ends up happening is there's 2 sets of contacts here. There's a set across the top and there's a set across the bottom. And when you switch this into forward, this forward plate, this connection is made across on top, and there's a second one made across on the bottom. When you switch this to reverse, the one here that I've marked as R connects across the top and also across the bottom. And the center one, which I haven't marked at all, actually connects both ways. So if you have it forward or if you have it in reverse, it doesn't matter, it switches on. So we're not gonna use that one. Now, what I need to do is I need to switch a common wire to either the forward or the reverse wire to control the VFD. So what I've done is the original lathe had, I don't know if you can see this, there's a shorting bar installed across these. It connects all the way across all 3 of these terminals on this side. So what that will do is I can connect the common wire here, and it'll be connected to both the forward and the reverse switch. Then I can connect the forward wire here, the reverse wire here, and that should be good to control that. Now, for the start and stop switch, or start and stop switch, we want to connect those up to control the contactor. Now let's talk for a minute about exactly why we're using the contactor in this way. We're going to set it up so that it's latching, which means that you have to pull out the stop switch to enable power, but then you have to actually press the green button to momentarily to start it, and then it will latch and stay on until you press the stop switch. Now, there's a couple of reasons we do this. One is just to prevent accidental starts to the machine. It also makes it so that when you hit the stop switch, it completely disconnects the electrical power for safety. But the other thing that this does is because it uses power to latch on, if you lose power to the machine for some reason, the latch will release, and then when power returns, the machine won't switch on automatically. You'll have to actually hit the green button to start it. So it's really easy if the machine was running and you have a power loss situation and you're running around trying to get the lights on and trying to deal with that, to forget that the machine was actually switched on. And when power comes back later, you don't want the machine to suddenly start unattended. All kinds of bad things can happen. So that's one of the reasons we use a latching contactor switch. Now let's talk about how we make that happen. I drew up a horrible little schematic here, and hopefully you can see this. Now, the way the contactor works is it's just a big relay. So you have an electromagnetic coil, that's what this symbol is here, linked to some switches. Now this contactor has, I think, 3 or 4 power legs. I think it's 3, so it can switch 3-phase power. And then it's got 4 additional auxiliary switches that are used for various things, and we're going to use one of them for latching. And we're going to use one of the normally open switches. So when this electromagnetic coil gets energized, it closes that switch, turning it on. And so what we've got here, the way the latch circuit works is it's set up, we've got the coil, the power from the hot lead comes in across that switch, which is normally open, and then through the coil and back to the neutral. And so what that means is that once this turns on and that switch is closed, then the current will flow through the coil and it will keep it on. And then to turn it off, we have the stop switch in series with that power. It's normally closed, but when we hit the stop switch, that'll open. It'll turn off this electromagnetic coil. That switch will open, and then even if the stop switch closes again, it won't matter, it won't come back on because there's no path through this open switch to re-energize the coil. Now to start it initially, we have the start switch connected across that. So as long as the stop switch is out, we press the start switch and the current will flow through the start switch, through the coil, energizing it. which will then close this auxiliary switch, allowing then, even if you release the start switch, the current to continue to flow through the coil. And then again, you just hit the stop switch to open it and it resets. So this is what we're going to wire up, and we're going to use a separate wire for the emergency stop for the contactor. Since this is 110 volt AC, we're going to use a different wire for this than we use for the potentiometer for the variable frequency drive and the switches to control the direction. That's all low voltage, and we don't really want that in the same cable with 110 volt for the contactor. Okay, before we go any further, let's go ahead and mount the potentiometer here. And again, it just goes through the hole that we just made. There's a washer and a nut. And let me grab a little wrench to tighten that. I love this little 4-inch, I think it's a little 4-inch crescent wrench. When I was a kid, this is the first tool I ever owned. I was spending time with my grandpa in his shop on the farm, and he took me down to the hardware store because he needed to buy some parts for a tractor. And we went in, and they had a whole bin of these by the register. And I didn't know this at the time, but this was kind of a rite of passage for me and for all of my cousins, is when Grandpa bought us our first tool, and this is what we all got, was a little 4-inch crescent wrench. And that's now got to be 40 years ago, and I still have it, and I still use it all the time. I don't have to worry about this rotating because we have this little pin. Get that nice and tight so it won't go anywhere. Okay, and that's the potentiometer. I won't worry about putting the knob on it right now. Okay, and let's talk about the cable we're going to use. Maybe. Okay, this is the cable that we're going to use for all of the control wiring, and this is a 9-wire plus ground shielded cable. Let me go ahead and peel some of this insulation off. So you can see this has got a foil shield, and then wrapped around the foil shield is a drain wire, and this is the ground. Now we're not actually going to connect the ground on this end because the ground is connected at the VFD, and we don't want to connect it at both ends. We've got the common reference wire in here that we're going to use for the signals, but we don't want to actually connect the ground because we have potential then to create a ground loop. So at this end, I am just going to snip off the ground wire, and I'm going to snip off the foil insulation. And just to make doubly sure we don't end up with any kind of connection there, I'm going to put some heat shrink tubing on it. Okay, the heat shrink tubing then will keep that all nice and neat. It'll keep anything from getting into the end of the cable, and it will also make sure that we don't end up accidentally making electrical contact between the shield and anything that's in here. Okay, we've got a bunch of wires in here and a nylon packer, which I should have trimmed earlier. And let's talk about color code. So, this is my plan. Hopefully you can read that. If not, I'll have to put something else up on the screen. So the wires in here, black, brown, red, orange, yellow, green, blue, violet, and white. And what I'm planning on doing at this point is I'm going to use the first 6 wires for the common and the 5 switches on the VFD. Now the only thing we actually need to use on the VFD, we need the common, the forward, and reverse right now. But I've got the extra wire, so I'm going to go ahead and just hook up The other 3 wires, they will be connected at the VFD, but there'll be nothing connected on this end, and there's nothing programmed into the VFD for those. But at some point in the future, we may want to add something, like we may want to add some jog buttons for threading, for example. And then the last 3 are going to be, the blue, violet, and white are going to be the analog ground, the analog voltage in, and the 10 volt that are used for the potentiometer for the speed controller. So right now, S3, S4, and S5 are not going to be used, so I'm just going to tuck those back out of the way. And I'm just going to zip tie those down just so that they're not flying around free, because again, we are going to have 110 volt in here, and I do not want these coming in contact with that. Now, if you never seen one of these, this is a zip tie gun. These things are magical if you do a lot of zip tie, a lot of cabling work. Just goes on, squeeze, it pulls it tight, and trims the end. Like I said, if you do a lot of this, they're magical. Okay, so now to hook this up, we're going to have the black, brown, and red are going to go to the switch, and the white, blue, and violet are going to go to the connectors that I already have here on the potentiometer. So let me just get those all connected and crimped. Okay, those are all the connectors. Let's attach it. When I took all of this apart originally, I had to take these switches off to be able to get at these screws. But I think I'm going to be able to do this without resorting to that this time. Okay, there's that. Now let's hook these up, figure out which way this is going to go. So the high side wire is the red one here. Now if any of this is a problem later, like if it goes the wrong direction, it's an easy thing to just swap these connectors around. Okay, now let's look at what we're doing for the stop switch. Stop switch is going to be this cable, which has got 4 wires in it, also shielded with the same kind of foil and ground. And same drill, we're not going to use the ground, we're not going to connect the ground at this end. Grab a piece of heat shrink. Again, we're going to be connecting the black wire to one side of the stop switch. The other side of the stop switch will hook to the red wire and the start switch. And then the green wire will be on the other side of the start switch. So we do have to make the connection because we're going to be connecting the stop switch and the start here. We need a jumper, and I just salvaged a jumper from the original lathe wiring. Okay, so that is all the wiring on the back of the control panel for the lathe. Now we just need to take this back over, put it in the lathe, and route some cabling. Okay, we've got the control panel here ready to go back in the lathe, and we need to route the cables. And we've got 2 cables here. We've got a high voltage cable and a low voltage cable, and I'm just going to run these back through and into the original control box on the back. There's the high voltage cable and the low voltage. There's actually 2 holes in the casting, and I'm just going to stick these through different holes. Now the last thing that we have, there's one more piece of wire we haven't hooked up yet, and there's a ground wire. And this just connects the control panel to the chassis of the lathe. This is just connected to the casting in the back. There's another wire that I already hooked up from the casting here down to the casting of the motor in the back. And again, these are wires that were already in the lathe. And then there's one more, and that is the motor, as you saw in probably the very first video where we were wiring it up. It's actually connected to the ground that goes all the way back to the electronics box over on the wall. So I just need to complete the circuit and connect this to one of these grounding points on the front of the panel. Okay, now I just want to make sure we're hooking this up in a way that's not putting a lot of weird strain on the cables or causing the cables to end up in any part of the exposed spindle that's in here. Okay, so I think I've got all this routed so that these cables will stay put and will not go anywhere near the rotating spindle when this thing is bolted down. And so let's go ahead without further ado and screw it in. This may not be the best knob for this. I'll come up with something better later probably. But there we go. Now we have a speed control knob solidly mounted on the front of the lathe. Turn that all the way down to the minimum for now. Make sure the e-stop switch is in, just in case when we start getting things hooked up. And now I think we just need to go to the other end, get the cables run into the box and connected. And then we should be ready to run. Okay, I went ahead and got all the cables routed out of the back of the lathe. Up here, they're zip tied together, and you're not technically supposed to do that because now we've got the high voltage motor, high voltage, high current motor cable coupled right next to the low voltage cables here. I don't think it's going to be a problem. I think I'm going to get away with it. And if not, then that's the first thing I'm going to do if I start having like intermittent triggering or errors on the VFD. The first thing I'll do is just separate those wires and see if that's the issue. So here's the contactor. Now before I work in the box, I have it unplugged. So no need to worry that I'm going to electrocute myself, at least not right now. So this is the cable for the contactor, and probably the most difficult connection to make is going to be to get this on that common ground lug. So let me start with that. And there's already a jumper from the neutral down to one side of the coil, and from the start wire over here down to the other side of the coil. Now let's bring over and do the the motor fan wiring. So I'll just hook up the common wire here and the other side of this pin. Now all of these cables now have these crimp terminals on them just to make these easy to make connections, so we're not worrying about wires being frayed or coming free in here. So that goes to the other side of the relay. And now we've got 12 volt power, comes across, powers this fan, and is hooked up through the relay to the fan over on the lathe. Now, the control wire. Let's start by getting the ground down there on that loop. Okay. Okay, now I've just got my color code handy here, and I'm just going to go down and hook the rest of these up. That's all the connections made. I'm pretty happy with the cable layout in the box. All the grounds are in. The only ground I did not connect was here, and that is the ground for the fan, the DC fan wiring. I didn't bother with that. Again, I don't think I'll have any trouble, but if I do, we'll come back later and do it. Let's see, all the glands are tight. I think we're ready to put some power to this thing and do our first test. Okay, well, we've got everything wired up. We've got everything in the box. We've got the control panel wired up, all the controls connected. I think we're ready to run. Okay, first thing to try is the contactor. Make sure that's working. So I'll open the e-stop switch, or actually close the e-stop switch. Now you note that nothing's happened until I press the start switch, and that should close the contactor. And there we go. We've got power to the VFD, and I feel airflow in the box. We won't run it. We won't run it with the box closed until we're done testing here. So let's power on the lathe and see what happens. See, the variable speed appears to be working and go all the way up to 120 hertz. Let's start with it down at 6 hertz, and without further ado, switch it into forward. And there it goes. Now I've got this set right now. Turn that off. I have this on the middle belt on the high range, and that should get us to 1200 RPM. But if we go all the way up to 120 hertz, that'll take us all the way up to 2400. But turned all the way down at 6 hertz, we should be turning about 120, which is what you're seeing right here. Now in a minute, we'll try it on the low range and see just how slow we can go. For now, this is forward 6 hertz and reverse. And boy, that is so quiet compared to what it did before. Okay, let's take it up and see what happens. It's quieter than it was. That's about 1200 RPM. Let's go all the way up to 2400. No problem. Now let's reverse it. It should spin down in 6 seconds and then spin back up in another 6. Back to forward. And off. Well, ladies and gentlemen, I think we've got variable speed on this lathe. Just out of curiosity, let's see how slow this thing will run. Now, we can run this right now down to 120 RPM. Now, it remains to be seen if there's enough torque there, but this is 120, which is slower than the lathe could go before. But since we do have it in high gear, there's going to be limited torque. If we want more torque, we've got to run it in a lower gear or a lower belt. Let's take it all the way down and see just how slow we can run this thing. So we'll go back to the low belt and we'll go to the smallest pulley on the counter shaft. You can't see that. We'll go to the smallest pulley on the counter shaft and the largest pulley on the spindle. Tension that up, and so now this should be the lowest speed. Now normally that would be 150, but since we're running it at 6 hertz, that should be 15 RPM. Let's give it a shot. Okay, that's glorious. Now, I could stop it, but I think I'm making the belts. I don't think I have the belt tight enough. Yeah, it's just the belt slippage, and we'll deal with that. Okay, now what happens if we run this up? So in theory, this should go up to 300, but I don't know if I want to run all that gearing that slow, that fast. Let's find out. And you're just hearing the teeth on the counter shaft rotating. Probably not really going to run it that slow on a regular basis, but that is slow. Okay, well, I think that's everything working. If I missed something, put it down in the comments. I'm sure you will. And hit the switch to turn off the contactor. And there we go, and now the capacitors will bleed down in the VFD. I am curious whether I can read the numbers. I did this strategically so that the numbers would line up behind this grill. Let's see if we can actually read those. Turn it back on. See, can you read those on camera? I think so. That says 6 hertz. And I should be able to run that all the way up. I want to go 60. There's 60 hertz. There's 120. Well, that's pretty good. I can actually see through the fan grill. And reverse. And off. Well, that is the variable speed upgrade for my lathe complete. It is definitely going to make this easier to use for future projects. That's all for today. If you're enjoying these videos, please give me a thumbs up. Also, be sure to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.